Hello and welcome all. So guys, I'm Rahul Kaushik and I welcome you all on Unacademy guys. And after I hope you guys have enjoyed your Diwali vacations. And after Diwali guys, I'm back. So we are doing the rapid revision and for the target 2021 guys. For this, we have already covered some lectures and currently we are doing periodic table. Okay guys. So I hope you are ready for it and again, I wish you a belated happy Diwali, Govardhan and Vaya Divas. So guys, let's start today's class with the rapid revision and that is for target 2021. Okay guys, so today I'm going to take atomic radii, right? So what do you mean by atomic radius? What do you mean by ionic radius? What do you mean by crystalline radius? So we are going to cover each and every point today. But before I start today's class, let me tell you something about myself, guys. I'm Rahul Kaushik, and I worked in Mansa Classes Kota for continuous 10 years, and I was head of department there. And guys, I co-founded my own organization that is Zigyan Education Private Limited. And now, along with Zigyan, I'm here on Unacademy, India's largest and fastest growing online platform. Okay, guys. So I have mentored 2000 plus IITians till date, and now guys, I will tell you some simple steps how you can subscribe to Unacademy. So step number one, just go to Play Store or App Store, download Unacademy's learning app. Okay guys, once you have downloaded it, install it guys, and after installing it, yes, you will be directed to this page. On this page, you have to click on the plus. So once you are clicking on the plus, then you have to choose IIT JEE as your goal. And once you choose the IIT JEE as your goal, guys, then you have to hit the subscription button. Okay. So once you are hitting the subscription button, you will be directed to this page. On this page, guys, you have to select either for 12-month program or for 24-month program. Okay. And don't forget my code, that is Rahul Chem. If you are applying this code, guys, then you will be getting a flat discount of 10%. Okay. So guys, don't forget this code Rahul Chem. Rahul my name and Chem for chemistry. Now I will tell you what are the advantages which you will get. So actually for 1 year the fees is 38,000. For 2 years the fees is 56,000. But if you are applying my code Rahul Chem, then your fee will be, for 1 year you have to pay just 34,600, and for 2 years you have to pay 50,400. Okay guys, so I'm again asking you to remember this code. It will help you in getting 10% off. It will help you in getting 10% off. Okay guys, so this is what amount, this is what the fees you have to pay. But guys, now let me tell you what are the advantages of joining Plus. What are the advantages? So here guys, let me tell you the point number one. On the Plus, the course would be structured, right? So on the YouTube, we are also providing you the complete theory lectures, but when you are preparing for any competitive examination, just theory is not enough. Just theory is not enough. Along with theory, you have to do the application part. And along with that application part, numericals are very important. So structure means after every class, you will be getting DPPs, you will be getting modules and all these things. Okay guys, DPPs, modules, and then you will have live quizzes there, and after completion of every topic you will have mega quiz. Okay guys, and DPPs and modules are very important. Suppose I'm taking on the Plus, so I've completed suppose mole concept, so I'm providing the DPPs, I'm providing the modules in which the students can practice, and only through practice, yes, only through practice you can master the application part. Hi Priya. Hi Sanjeevni Tiwari. Hello everyone. So guys, get ready for it, because periodic table this time in the JEE Mains, there were 10 to 12 problems from the periodic table. So intentionally 10 to 12 questions in the September attempt. Okay guys. So intentionally I took this topic so that you guys can revise it. Okay, so again I was telling you the benefits of plus program. Course would be structured, you will get DPPs, you will get module, there would be live quizzes, there would be mega quiz, and after that, not just mega quiz and live quizzes, guys, you will have access to video lecture and content of all the educators. Like suppose you're preparing for IIT, then it is not like you will just have access to the video lecture and content of me, but guys, you will have access to the video lecture and content of all the educators who are there teaching for IIT. Okay, guys, and the most important part, yes, you will have access to the iconic test series conducted by Unacademy. So that is very important, guys, because in Unacademy's test series, there are so many students who are taking those tests. So the test series is important for you. Okay, guys. So these are all the benefits, guys. Let's start now. Let us start now. In the previous class, we have already covered the Slater's rule and all those things. Yes. Let me tell you. Yes, in the previous class, we did screening effects. We did Slater's rule. Okay, guys. And now we are going to start. Atomic Radius. So, are you ready, guys? Are you ready? Hello, Sanjeevni. So when we are starting atomic radius, so first of all, what do you mean by atomic radius? Actually, when I'm talking about the atomic radius, the radius of atom is not like a lemon, right? So atom is not like a lemon. Suppose if I'm taking a lemon, then that lemon will be having a well-defined boundary, right? And you can say this is the radius of lemon. Suppose this is lemon. But the problem is when I'm talking about the just a minute. When I'm talking about the atom, so this is positive charge. So you cannot define this boundary. Why? You cannot define this boundary. The problem is suppose this is nucleus, so we can have electrons. Now we plot electrons in terms of electron density, right? Suppose here electron density is high, so I will say that at this point the probability of finding an electron is maximum. Electron even can be found at a very far away distance, right? Yes, electron can be found even here, but I will say up to this point the probability is maximum, so I will say this is the radius. Someone else might say, no, this is not the radius, I do not agree with you, and he or she might say like this will be the radius. So it is not a well-defined boundary. Yes, it is simply approximate distance. Okay, guys, it is simply approximate distance. So it is the distance from nucleus up to which probability of finding an electron is maximum. Okay, guys, it is the distance from the nucleus up to which probability of finding an electron is maximum. Note it down, guys. That's very important. So what do you mean by atomic radius? Now you know it is the distance from the nucleus up to which probability of finding an electron is maximum. Okay, guys. So now you know the atomic radius. So guys, what are the difficulties? What are the difficulties which we face while measuring the radius of an atom? So guys, when we are talking about the radius of an atom, suppose I'm talking about helium, neon, argon, krypton, xenon, radon. These are the gases which exist in monoatomic state. So you can determine their radius. But most of the gases, guys, like we have hydrogen, oxygen, nitrogen, ozone, most of the gases do not exist in atomic state. Except these, most of the molecule like we have P4, S8, most of the molecule never exist in atomic state. Even if you try to break them in atomic state, they will be highly unstable. So how will you measure their radius? So the first problem is atoms are generally found in molecular state, not in isolated state. So how do we measure the atomic radius? Then guys, we have second point. Their size is very small. The size of atoms is very small. Hi Varun, the size of atoms is very small. Suppose I ask you to measure the diameter of this tip or radius of this tip, it will be difficult. Rather, if I ask you to measure the radius of this glass, the mouth of this glass, you can easily measure that. So as things get smaller, it becomes difficult to measure their size. It becomes difficult to measure their size. Okay, guys. So the second difficulty is their size. Their size is very small. And now the third point is boundary of atom is not defined exact. Keeping in mind all above points, it is very difficult to exactly determine the atomic radius. Okay guys, now I just told you what are the difficulties in measuring. So guys, we have three types of atomic radius: covalent, metallic, and van der Waals. Now why do we need it? So guys, if I talk about the metals, suppose I am taking these metals. So in these metals, yes, there is metallic bonding. So we measure the metallic radii or the crystal radii because they exist in form of crystals. But if I talk about these gases H2O2 and 2, these do not have metallic bond. These simply form covalent bond. So in this case, I will measure the covalent radius. Okay guys. So it is not like for every atom I can measure all three kind of radius. No. If that metal, either that element will be forming metallic bonding, or that will be forming covalent bonding, or that will be having simple van der Waals forces. So I'm going to discuss all these points. So in which case, what we have to do? Okay guys, so let's move ahead. So covalent radius. So what is covalent radius guys? Now it is half of the distance between nucleus of covalently bonded atom, and it is generally used to determine radius of non-metal. So guys, let me tell you, yes, this is hydrogen, HClO2. So when two hydrogen atoms are overlapping, right, this is the bond formed by sharing of it, one electron. In HCl they are sharing it, in O2 they are sharing it. So 4 electrons are there, so I will make double bond, means 2 bond pair are there. So yes, here you can observe guys, here yes, enmeshed. So the radius, this is the distance between the nuclei. Suppose I am doing it, this is the overlapping. So this is the distance. Suppose this is it. So I will also call it the bond length, DAA. So what will be radii of it? It will be DAA by 2. Okay guys. So now atom is considered a flexible sphere just like cloud. It is. And what is the covalent radius? What is the covalent radius? Now you know that covalent radius is half of the distance between two covalently bonded nuclei. Right? It is half. It is half of the distance between two covalently bonded nuclei. Okay guys, got it? Please ask me if you have any doubt. Ask me guys if you have any doubt. No doubts? Okay. Any doubt? Yes, Priya, Sanjeevni, Varun. So now you know what is the covalent radius. It is half of the distance between nucleus, and it is generally used to determine radius of non-metals, guys. Non-metals. Now you know it. So for non-metals, now let's talk about the case one for homoatomic molecule. Homo means only one kind of atoms are there. We have H2, we have N, we have O2. So this is the A, this is the A. Both will be same. So DAA will be the bond length. DAA will be the bond length, guys. And here I can say the radius of A will be equal to PAA by 2. Got it? Any doubt? Please ask me. Any doubt? So similarly, if you want to find out the radius of hydrogen, it will be bond length. It will be bond length between HH by 2. Radius of nitrogen, it will be bond length NN by 2. So in case of N2O2, you know that there are 2 bond pair and 3 bond pair respectively. Got it? So guys, the problem arises when we have heteroatomic. So in case of hydrogen, yes, this is 74 picometer. So the radius of hydrogen is 34 picometer. In case of fluorine, this length is 142 picometer, and radius of fluorine is 71 picometer. Okay, guys. So can you tell me now? You know the radius of fluorine, you know the radius of hydrogen. So this is the hydrogen, suppose, and this is the fluorine. Can you tell me the bond length of this? Anyone? Can you tell me the bond length of this, guys? Yes, what should be the bond length? DHF. So it should be RH plus RF, and it should be 37 plus radius of fluorine is 71. Okay, guys, radius of fluorine, it should be 108 picometer, right? As per our expectation, this bond length should be 108 picometer. Got it? But guys, let me tell you, this bond length is not 108 picometer. This is expectation, guys. And when we talk about the reality, so let me tell you that this bond length DHF, it is approximately 92 picometer. And you know that 1 picometer is 10 raised to the power minus 12 meter, and 1 angstrom is 10 raised to the power minus 10 meter. Got it? So always remember this thing. Guys. 1 picometer and 1 angstrom. So the problem is, it should be as per our expectations. It should be 108. Just a minute. So RH RF, guys, it should be 108 picometer. Yes, this is our expectation, right? But it is 92 picometer. This is reality. So you might have seen in movies expectation versus reality. So guys, the similar way I'm talking about it. How will I explain this? So these are some examples of chlorine. Let me change the color. We have fluorine here, we have chlorine, we have bromine. So for homoatomic, you can easily measure their radius. This is experimental data, you don't have to remember it. Now for heteroatomic molecule, in heteroatomic molecule we have different type of atom. Here we have HCl, HBr. Hetero means different, homo means same. Got it? So suppose now we want to find out the bond length of HF. So it will not be like simply RH plus RF. Okay, guys, because we have done this. So expected is 108, but actual is 92 picometer, the HF bond length. So to eliminate this problem, to resolve this issue, why? Yes, Suraj, you are right. Yes. So electronegativity, we will do it in the next class, but right now I will talk about it. Yes, Shoemaker Stevenson suggested a formula for it. And what was that formula, guys? Yes, Shoemaker Stevenson suggested a formula to find out the bond length of heteroatomic molecule. And what was that formula? So DAB will be RA plus RB minus 9 into delta X. Delta X is electronegativity difference. Yes, Suraj, you are right. So he considered the electronegativity difference. Okay. So now the electronegativity for hydrogen is 2.1. For fluorine it is 4. And you put it here. So you will be getting 37. You will be getting 71 minus 9 into the difference will be, guys, it will be 1.9. So it will be approximately 92 picometers. So this is the bond length of H and F. So if you are considering the electronegativity difference, then you can find out. So this is Shoemaker-Stevenson formula. This is Shoemaker-Stevenson formula and you can use it. Got it? Any doubt? So where do we use it? Where do we use it? For heterogeneous, heteroatomic molecules, right? You cannot use them everywhere. So now remember this formula. If your radii is in angstrom, then instead of 9 you have to use here. Then instead of 9 you will have to use here 0.09. Okay? Because you know that 1 picometer is 10 raised to the power minus 12 meter. And 1 angstrom is 10 raised to the power minus 10 meter. If you divide it, so you will be getting 1 angstrom is equal to 100 picometer, or 1 picometer is equal to 10 raised to the power minus 2 angstrom. So here it is coming 10 raised to the power minus 2. Yes, physics wala junior, surely I will explain. Today's topic is covalent. Today's topic is radii. Definitely in the next class I am going to take ionization energy and electron affinity. And surely I will take it in detail. Don't worry about it. Don't worry. Okay, physics pala. So just remember it, guys. There is a difference in the formula. Here we have 9. When you are using the radii in picometer, but here we have 0.09 when you are using the radii in angstrom. Got it? Any doubt? No doubt now. So let's move, guys, now to the next. What are the factors that affect covalent radii? What are the factors? So now you know that the covalent radii, the factor affecting is electronegativity. Yes, number of bond multiplicity. What do you mean by bond multiplicity? So let me talk about it. Suppose I am talking about CC, C double bond C, C triple bonds. Yes. Can you tell me which bond will be the largest? Single bond, double bond, or triple bond? Write down in the chat box, guys. Which bond will be the largest? What are the factors that affect covalent radii? First factor is electronegativity. We have already done a formula over that. Yes, the electronegativity difference you have calculated. And then the bond multiplicity. So guys, which bond will be the largest? Yes, students, can you tell me now? So we have here CC, C double bond, and this. Got it? This is the order of bond length. So what can I say? As bond multiplicity increases, double bond, triple bond size decreases. Yes, it is the strongest and the shortest order of bond. Okay, order of bond length. So this is triple bond, double bond, and single bond. Got it? Any doubt, Suraj? Okay. So then we have screening effect or repulsion power. So if I talk about the radius, it is inversely proportional to S. More the repulsion, S or sigma, it represents repulsion, right? So if repulsion is high, what will happen? If repulsion is high, then the radius will increase. This is positive. 2 electron, 8 electron. So what I'm telling you guys, in this case if repulsion is high, then this will expand or radius will be high. Got it? So screening effect. So larger the screening constant, larger will be the radii. Got it? So larger the screening effect, larger will be the radii. Any doubt? Any doubt, guys? No doubt now. So let's move now. Let's move now. Let's talk about the metallic or crystalline radius. So this is the point. So till this point, I was talking about the covalent radius, but the covalent radius, we talk about the covalent radius for the molecule which form covalent bond H2, O2, N2, H2, HCl, because among all these molecules we have covalent bond. And what is covalent bond? Yes, these bonds are formed by sharing of electrons, right? But if I talk about the metals, Na solid, Mg solid, and iron, copper, zinc. So in these all these metals, we don't have any covalent bond. So why do we talk about the covalent radius for them? In such a case, we have for the metals, guys, keep on liking this lecture. For these metals, we use metallic bonding, right? In these metals, we have metallic bonding, and that metallic bonding is there in between. Just a minute. In between metal atoms, in between metal atoms, we have metallic bonding. Okay, guys. So in case of metallic bonding, we will use the metallic or crystalline radius. So in metal, when I'm considering the metal atom, there is one important point. Yes, in this case, I will not consider the overlapping. This is metal 1, this is metal 2. It will be like marble. हमने कंचे देखे होंगे ना, मार्बल बचपन में हम उनसे खेलते हैं, right? So in this case, guys, I will consider the atoms as rigid spheres, right? And if you remember in covalent, let me show you. Just a minute, guys. What was the assumption? The atom is considered as flexible sphere, just like cloud, right? Yes, Chandra Joshna, I'm taking classes in the pure English, and already I'm taking classes there. So you can join the plus. You can join the plus using the Rahul Camp. Yes, we are teaching over there, so don't worry. Yes, Unacademy has taken your problem into the account, and currently, yes, you can join it. Yes, you can get it on the plus. So I'm already taking the classes for 11, 12th and dropper batches. Right, Jyotsna? Joshna? Hi, Gulsekhar Zakka. Guys, keep on liking this lecture. Keep on liking it if you are really enjoying it. So Joshna, you can use it using my code RahulCam. And you will be in my batch. You will be getting a flat 10% off. Okay. Hi, Gulsekhar. So you will be getting, and there we will be teaching in pure English. So guys, atom is considered as flexible sphere in covalent radii. But when I'm talking about the metal, you know that they are tough. So we don't consider them as flexible rigid spheres, right? So it is half of the distance. So if this is the distance between A, got it? So if this is the distance between A, so the radius of A will be dAA by 2. Got it? Yes. RA will be equal to dA by 2. So again, this is half of the distance between two atoms present in the metallic crystal. It is used to measure the radius of the metals. Got it, guys? It is used to measure the radius of the crystal. So guys, here you can see there is no overlapping. And if this distance is 372, so the radius of Na will be 2 by 2. You will be getting 166 picometer. I hope now you got it. No, Gulsekhar. Currently, we should not talk about it. Surely, I don't think in January it will take place. But don't worry. You should focus on your study. So guys, this is the crystal. where we have the sodium. Okay, guys, this is the crystal where we have the sodium atoms. Got it, guys? So they are not flexible. Atoms are considered as rigid spheres, which cannot overlap with each other. Got it? Which cannot overlap with each other. So now you know the metallic radius. Any doubt? Any doubt? Yes, Ananya. So now let's talk about the van der Waals radius. So guys, we have three types of radius. The first one was covalent. The second one was metallic, or we also call it crystalline radius. And then we have the third one, that is van der Waals. So what is van der Waals radius? So guys, if I talk about the van der Waals, so suppose we have helium, neon, argon, krypton, and these are all gases. So their atoms will keep on moving in all directions randomly. Got it? Their atoms will keep on moving in all directions randomly. Helium, neon, argon, krypton. These are all the gases, guys. And if we talk about these gases, so what will happen when you solidify them? So in solid crystal, we have helium, 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 helium. So there will be no overlapping, and these will be at some distance far away from each other. Because in between two helium atoms, there will be weak van der Waals forces. In between two atoms, there will be weak van der Waals forces. Official gamer, we can take this. When is the JEE 2021? I'm not the right person to answer it. Let's see whenever it happens. So if we get any information regarding that we will share. But we cannot talk in terms of rumors only. Right? Once we get some concrete information, then surely I will be taking a session over that. Okay, guys. So for noble gases, it is half of the distance between center of two noble gas atoms attached with each other through weak van der Waals. So when I'm talking about the noble gases, suppose we have helium. So obviously they will be at some distance, right? So in that case, yes. So radius of helium will be this. Got it? Any doubt? So van der Waals radius is measured generally in solid state. Because if gases are moving, gaseous particles are moving, how will you measure their radii? How will you measure? Right? First of all those atoms or molecules should be static. Suppose something is moving like it and I ask you to measure its radius. It is already so small and then it is moving, you cannot measure. So first of all, what you have to do, you have to solidify it, and then in the solid you can measure this. So it will be at a far distance. Van der Waals radius also depends upon the environment. So it will change. Like if I talk about the radius of xenon. So suppose we have xenon atoms, right? And from this data we can measure the radius of xenon. But if I talk about the XeF4 and I measure the radius of xenon here, then it will be different. So van der Waals radius also depend upon the environment. Right, guys? So radius of xenon is 220 picometer, van der Waals radius. But in XeF4, radius of xenon is found to be 170 picometer. Why? Because environment around xenon is changing. Okay, guys. So the radius of a van der Waals radius you can easily calculate. But in this case, the kind of force that will be there between two atoms or molecule will be the van der Waals force, right? In covalent radius, the kind of force is the covalent bond. In metallic radius, the kind of force is the metallic bond. Okay, guys. I hope now you got it. Got it? Now, this was the van der Waals radius for atoms, for noble gases. Now, if I talk about the molecules, guys. So, suppose we have H2. We have one more H2. Right? So, these are the radius formed by overlapping. So, I will call it, guys, covalent radius. But here, this distance, yes, this one. So, this will be the van der Waals radius. So, the van der Waals radius of hydrogen will be dH2H2 by 2. And what is this is the van der Waals radius, and this is the covalent radius. So what will be the covalent radius? And what is the DHH? This is DHH. This is DHH. So guys, obviously which radii will be larger? Can you tell me? Which radii will be larger? Be fast. Which radii will be larger here? So in this case, this van der Waals will be larger because we are measuring a different thing. Okay, guys. So when we are talking about for the hydrogen, if we are measuring the van der Waals and we are measuring the covalent, van der Waals will be always greater than the covalent because the way these are measured will be different. So now these are all the points which I wanted to discuss with you guys. So now it is clear. So this is a hypothetical question. And what is that hypothetical question? If it is possible to measure all kind of radius for an atom, then van der Waals will be very, very greater than the metallic. Metallic will be very, very greater than the covalent. Got it? Any doubt? Any doubt, guys? Got it? Okay, so now let's move. Yes, now we will talk about the periodicity. So if I talk how radius will vary within a period or within a group. So if I talk about in the period, this is lithium, beryllium, boron. And when we are moving in a period from left to right, lithium, beryllium, boron, carbon. So what is going on, guys? Here we are having 3 electron, 3 proton, 4 electron or 4 proton, 5 proton will be. But the new electrons are added in the same shell, in the second cell only. Got it? New electrons are added in the same shell. Any doubt? So what will happen, guys? The force of attraction will increase because what is the formula for force of attraction? Q1 Q2 by R square. So R is not changing. You are adding the electron in the second shell only. So this attraction will increase because the force on the positive charge on the nucleus and the negative charge due to number of electron is increasing. So when we move left to right, in general, size will decrease. And when we move top to bottom, guys, what will happen? So here we have lithium. Then we have sodium. And then we have potassium. So guys, this is second period, this is third period, this is fourth period. So when we are moving top to bottom, at every step, one extra electron is added, one extra shell is added. And due to addition of that extra shell, size will increase. Hi PNC, good afternoon. Got it? So let's talk about it. While moving left to right in a period, Z effective increases. As a result, size decreases. Force of attraction on outer electron. So guys, this will be the order. If we're talking about lithium, beryllium, boron, neon, because for neon we will measure the covalent radius and that is totally different. So it will be very larger, and generally we do not compare van der Waals radius of one atom with the covalent of another. Okay guys, so in this case this is lithium, and as we move left to right the radius decreases. Done. So when we move top to bottom, radius increases because new shell is added, but the problem arises with the boron, aluminium, gallium, indium. Only this. Okay, B and C, congrats. Finally, you went to school today. So, guys, this is the exception here. The expectation, yes, बैंगन आलू गाजर in thali. If I talk about, so your expectation should be like this. Got it? Boron, aluminium, but reality is different. And what is the reality, guys? Here we have boron, then we have aluminium and gallium approximately same, then indium, and again the thallium approximately same. So why aluminium and gallium are approximately same? Why indium and thallium are approximately same? Right? So now I will discuss it. But we can cover it only through the periodic. So what is the issue with that? I'm going to discuss that. Now I will explain you. So guys, this is the periodic table. Three D, 4D, 5D. Okay. LA. Got it? So here we have F block element. 14. So guys, boron, aluminium, gallium. So before gallium, we have 10 d electrons, 3d electrons, and d electron will have poor shielding effect. Poor shielding means poor repulsion, and poor repulsion means attraction will be very high. Poor repulsion means attraction will be very high. Got it? And if attraction is very high, so this size will be reduced and it is approximately equal to aluminium. Now what will happen? Why indium and thallium are approximately same? Before thallium, we have 10 5d electron and we have 14 4f electron. So overall we have 24 electron, D and F, and these 24 electrons is having very poor shielding effect. These 24 electron is having very poor shielding effect. Okay, so if shielding effect is very poor, guys, now what will happen? Can you tell me? So the repulsions will be very poor, but when 24 electrons are added along with that 24 proton are also added, so attraction will be very large. So size of thallium will be reduced to a large extent. As a result, indium will be approximately equal to same gallium and this. So in gallium we have only 10d electron. Here we have 10d and 14f electron. And you know guys that D and F is having very poor shielding effect. Due to this size decreases. We also call it, right? Yes, Chandra Joshna, once you join, let me tell you, once you join the plus, you can apply my code, that is Rahul Chem, RAHULCHEM, and on that you can follow me. Yes, you can follow me, and once you follow me, yes, you can send the messages to me. You will be able to send the messages on the plus. Yes, there will be option to follow me. Got it? There will be an option to follow me. So in that option, you can send me the messages. Any doubt? So Chandra Josna, once you are part of Plus program, yes, then you will be able to question me anything. You can send your queries, and there you can get all the material I have uploaded. Right now we have covered mole concept, redox, and we are doing the periodic table there. Right? And every fourth class is doubt clearing session on the Plus. So you will not have any doubts just now. Don't worry, you will have complete course. I'm teaching chemistry there. You have physics teacher, you have mathematics teacher. Ravinder Jasar is already teaching there. So we all are teaching there. All the educators on the JEE English. Yes. All the educators on JEE English are on the Plus as well. So we take regular classes on the Plus. Okay, Chandra Joshna. Yes, B and C. Lies D block. And cerium to lutetium, these are F block elements. So you can join the Plus and you can use my code. Just remember this code. You will be getting 10% discount. You are going to get 10% discount once you are using it. Okay. Rahul Chem for chemistry, Rahul my name. So guys, now it is clear why for D block there is no perfect trend. In D block generally first radius decreases, then it remains constant and then again increases. So guys, this is 3D. This is 3D, 4D and 5D. So ideally 3D and 4D, the radius of 4D should be greater than 3D. Yes, it is too much greater. But 4D and 5D we have approximately the same radius. You can observe here. 4D and 5D we can have approximately the same radius. Got it guys? Any doubt? Why this is so? So again this is due to, because here after the lanthanum we have 14 F block element, and due to this size of this D block element are reduced because those 14 F electron will have very poor shielding effect. Got it? And if they have very poor shielding effect, then what will happen guys? Attraction will be increased. As a result, the 5D and 4D will have approximately equal size. When you are moving 3D to 4D, the radius is increasing to a large extent, but 4D and 5D element is having almost the similar size, and we call it the lanthanide contraction. Okay guys, we call it the lanthanide contraction. Any doubt? So for D block elements, radius of 4D is greater than 3D, but 4D and 5D is barabar. Why? So it is due to lanthanide contraction. So now you know the meaning of lanthanide contraction. Yes, you can note it down. Lithium and hafnium onward. When we move right, 14 F electrons are added in each element, and these electrons have very poor shielding effect. Along with their 14 protons are also added. So along with 14 electrons, 14 protons are also added, and these 14 protons, okay Manish. So along with these 14 protons, along with 14 electrons, 14 protons are added, and now the net force of attraction will be increased. Okay guys, and the radius will decrease, it will shrink, and this is called lanthanide contraction. This is known as lanthanide contraction. So here you will observe the lanthanide contraction hafnium onward. Got it? Because before this is 57, this is 72. Yes, 14 electron are added. F block elements are added. Got it guys? Any doubt? So here you can see the lanthanide contraction 57 to 72. So you have 14 elements. And in those 14 elements you have 14 F electron. Very poor shielding effect. So hafnium onward, all will experience the lanthanide contraction, and the radii will be approximately equal to the radii of corresponding atoms. Like rhenium will have equal to technetium, rhodium will have osmium, rhodium will have iridium. Got it guys? Any doubt? So this is the lanthanide contraction guys. These are lanthanoids and these are actinoids. So what do you mean by inert pair effect? What do you mean by inert pair effect? So here if I talk, yes, what will be the configuration of it? 6s2, 6p1. So it can lose 6 electrons because before that, so the electron lost will be from here. So after losing one electron, these two electrons, due to very strong attraction, these two electrons will become inert. Why they will become inert? Due to very strong attractions. And if these become inert, then we call it inert pair effect. So it will be observed in Pb, Bi, Po and all that. As a result, Tl plus 1 is more stable than Tl plus 3. Pb plus 2 is more stable than Pb4 plus. Because the configuration of it will be ns2, np2. After losing 2p electron, these two s electron become inert. We call it inert pair effect. The s electron become inert. And this effect is called inert pair effect. Got it guys? So Tl plus 1 is more stable, Pb2 plus is more stable. So guys, I will take up the radius for cation and anion in the next class. Okay, but before that, let me tell you 3:30 p.m. 3:30 p.m. I again have a quiz on Unacademy's app. Right, I have the quiz on Unacademy's app. And let me tell you guys, 3:30 p.m. this quiz is based on the periodic table. So get ready for the quiz guys. Get ready for the quiz. So in the next class, I will be taking ionic radius and penetration effect, ionization energy, and what are the factors which affect the ionization energy. Okay guys, so today I have to take a quiz. So guys, if you really like this lecture, then please like it and share it. Don't forget to like it and click on the bell icon so that you can subscribe to our channel to get the latest notification of our lectures. Okay guys, so there are some simple steps how you can join the plus. Just install the app, click on the plus, choose your goal as IIT. Once you choose your goal, then hit the subscription button. And after hitting the subscription button, go for 24-month or 12-month program. And if you are going for it, yes, for 1 year the fees is 38,000. For 2 years the fees is 56,000. Okay guys, got it? So you just have to use this one. If you are applying my code, that is Rahul Ken, then you will get the discount. Then you are going to get the benefit of it. So instead of 38,500, you just have to pay 34,000. These are all the benefits guys which you will get. So for 1 year you have to pay 34,000. For 2 years you have to pay 50,000. Okay guys. So this will be a fee structure. And guys, 3:30 p.m. Yes, just after 5 minutes. Again, I'm going to start the quiz. Okay guys. So thank you guys. Thank you again. Remember this code Rahul again. Yes, this will help you in getting 10% off, guys. So bye bye, guys. Take care of you. Again, I will be meeting all of you in next 4 minutes. Next 4 minutes. Yes.